Okay, good morning, students. As you know, my name is Sudh Pandey, and you are floating with me in the world of physics. We are going through a chapter, and as you know, the chapter name is wave optics. So, in that particular chapter, we will start your next topic, and your next and the very most important topic, that is Young's double slit experiment. And before that topic, there is a subtopic, or we can say a very short topic, which is on your screen, and that is Young's double hole experiment. So what is basic Young's double slit hole experiment? What does it mean? What is its sense? So basically, if we talk about that, we are in need of to understand the Young's whole experiment. Then what should we do? Basically, we can simply say that Young tries to prove that the light is a wave. Okay, and to prove that thing, he performed an experiment. So that experiment is basically a very famous experiment. And before performing that experiment, he also done a short experiment that is a little bit famous, we can simply say, but very interesting. So in that experiment, what we can say Young's done. Okay, so if we talk about double hole experiment, then you can easily see that Young took cardboard. Okay, so let's suppose that this be your cardboard. Okay, and now this one. Okay, so this be your cardboard. And what basically he done that he make a hole in that cardboard. Okay, so let's suppose that this be your hole, like this way. Okay, and this be also like this way. You can now easily see that this is the hole which is made inside the cardboard. Okay, now what Young's done up to here? So basically he took a cardboard and then he make a hole in it. Then what he does, this is the very interesting concept, this is the very interesting thing. The next step, what Young's done after this step. Okay, so what is that step? So that step is he took another cardboard. Okay, so let's suppose this is your another cardboard, like this way. Okay, and in this cardboard he made two holes. So this is the first hole, this is the second. So basically जो है Young's took two cardboards, this be first cardboard, this be your second cardboard. In first cardboard there is a single hole, whereas in the second cardboard there is a two hole present there. So I hope that up to here each and everything is clear now. Okay, now what? These two cardboards are arranged in this way. So let's suppose this be your uh, one cardboard, this one is your another cardboard. Okay, so these two are, this is the first cardboard, this is the second cardboard. This one having one hole like this way, and this one having two holes like this way. Okay, and in front of first cardboard he placed we can say a light source. Okay, and after the second cardboard uh, he placed a another cardboard like the third cardboard. Okay, then a unique pattern he saw. What was that pattern? That pattern was that we can simply see that the light rays are like this way. So this be this be and this, okay, like this one, okay. And that is simple. We can say that I'm trying to feel you that what actually going on during the experiment. And this one like this one, then this one, okay. So it means you get some strips, okay, and the strips are in a definite pattern. So what is that definite pattern? The definite pattern means we can simply say that the green colored strip represents the brightness, okay. So maybe it is brightness, okay. So the next one represent the darkness. It means on that the third cardboard a definite pattern we get, and the pattern is in the form of strips. It means one strip will be brighter, other one will be dark, then bright, then dark, then bright, then dark. So this pattern goes on, okay. So this thing is very interesting, and Young named is that this phenomena is basically interference. So this phenomena means when light bends from the slits, these are the holes we can simply say, okay. So when the light bends from the hole, then it finally gives a new phenomena, and that new phenomena is called interference of wave. So in that particular phenomena we get a definite pattern in which we get several strips. So these strips are in a we can say in like a spectrum, okay. So the first one will be bright and the another one will be dark, then again bright, then again dark. So this pattern is appeared on the screen. So this is the experiment which explains that we have two waves. What I am trying to explain that according to Young, he says that if we have two light waves, so let be this one be your first light wave, and if we have second light wave, so it be your second light wave, okay. So as you can see here, so from the first hole the first light wave is coming out, and from the second hole the second light wave is coming out. So basically these two are the light waves which are coming from the two holes which are separated by a very small distance, okay. So after emerging out from the holes, these two waves superimposes to each other, and finally we get a resultant wave which is different in amplitude as well as in the phase difference. So this resultant wave has a unique pattern. That pattern we can see in form of brightness and darkness, and the resultant wave is known as the interference wave. So this pattern is a natural pattern which happens in nature, we can simply say, okay. And according to Young thought that because these two holes basically represent the source of the light itself, okay. So as you have read out, I have already discussed that we have a Huygens principle. In that principle we have the primary wavefront, then the secondary wavefront. So a little bit the quite similar concept is followed by the Young in his experiment. Means he take first cardboard and assumed as the primary wavefront, and the second cardboard having the two holes there, and a little bit we can say that the secondary wavefront. Okay. Or so we can simply say that in this pattern somehow the Young is also inspired by the Huygens, and he was trying to follow the Huygens theory. Simply we can assume. So that in this scene we have an idea that the interference is basically the concept of the superposition of the waves. It means there are several waves which are coming from the sources, and one unique thing is there, that these two sources are the coherent sources. So this one is the very important point, that very interesting point you should aware of. Okay, so what is the basic sense of the coherent source? So coherent source is that source which emits the light of the same frequency. So two different sources emits the light of the same frequency. Though, so the basic thing is that is this concept is we can say that a natural process, or it is an artificial process. So we can say that this phenomena is either we can say that this phenomena is in nature itself, but if we want to perform this experiment, then we have to choose some artificial sources here, because it is not possible that we can create two sources, two light sources having the same frequency. So we can say that nature has its unique property. Nature can do everything. So nature itself creates the coherent sources, but if we want to create, then we can simply say that it is impossible to have a natural coherent source. Okay, so we have to make the coherent source. So for that we or we can say the Youngs take the cardboard number 2 and make two holes in it. So these two holes behave like the coherent sources. So we are finally conclude that we have two major results here. What are the two major results? We have the two major results. That first one is that this is based on principle of superposition. Okay, so principle of superposition. So this is the first and the important thing, that the interference is based on the principle of superposition, and second thing, that the sources must be coherent, So we have an idea that how interference takes place in the nature. So the sources must be coherent, and the light coming from, or we can say the light waves coming from that coherent sources will superpose, and finally we get the interference wave. And the interference wave is in a definite pattern, in which we get the bright fringes and the dark fringes. So fringes basically represent the strips, so bright strips and the dark strips presents there. So I hope that up to here each and everything is clear to all of you. Now we will come to the main experiment, that is your Young's double slit experiment, as you can see on your screen. Okay, so in Young's double slit experiment, as you can see that Young's took a source which is passing through a lens. So this is your lens, or we can say that this is your convex lens. Why he took convex lens? Because the wavefront should be planar. So if we draw a wavefront on the light which is coming from that convex lens, so we get a planar wave front. Okay, so he took a source. In front of that source he put a convex lens, so that a planar wave front we get, and that planar wave front falls on the slits. So this is your slits. You can simply see here on your screen that slits means we can say that it also has the in Hindi that is your darar. Okay, so this is the slits. Okay, so light whatever light waves coming from the convex lens, or we can say the planar wavefront, that falls on the slits, and after passing from the slits we get the fringes on the screen. So fringes means as you can see, this is your bright fringe or bright strips, and this one is your dark strips or dark fringe. So in this continuity we get the bright fringe and the dark fringe. Okay, now we will see the mathematical setup of this experiments. Okay, so this is the main setup. As you can see here, we have source, we have lens, we have slits, we have screen. Okay, the light originates from the source, falls on the convex lens, becomes parallel, and we get a planar wavefront that falls on the slits, and from the slits we get the waves, and due to the superposition of the waves we get the bright fringe and the dark fringe on the screen. So this is your basic setup. Now as you can see on the second diagram, this is the mathematical diagram in which we can see that there are two slits, S1 and S2. So this is your first slit S1 and this is your second slit S2. So these two slits originating the two waves. So you can see here that your first wave, this be your first wave which is coming from the source S1, and the second wave which is coming from the source S2. So like this way. Okay, so I hope that this thing is clear now. So two waves are there, one is from the source S1 and another is from source S2, and these two waves are superposing. So this is the point P at which these two waves are superposing to each other. Okay, it means we can simply say that according to Huygens, okay, Huygens also proposed that the light waves are transverse in nature and propagates with the help of a medium, and the name of that medium is ether. Okay, so in the same pattern, Young's also believe that these two waves are transverse in nature. So basic equation of a transverse wave you can write down that it is y equal a sine kx minus omega t. So this is the basic or we can say the standard equation of a transverse wave, y equal a sine kx minus omega t. So with the help of this equation, he assumed that if we have two waves here, with one is coming from source S1 and another is coming from source S2, then there must be two equations. So first equation let be E1. So E1 will be E01, that is the maximum magnitude of the first light wave, and the sine that will be kx minus omega t. So this be your first equation of the first wave. So as you can see here that the displacement of the first wave is x here, that's why we take x only. But if we see that for the second wave, this is the extra displacement, or we can say the path difference delta x. So the net displacement becomes x plus delta x. So in place of x, for the second wave we have to take E2, that will be equal to E02 times sine kx and in place of x we have to put x plus delta x. Okay, so this thing is very notable, we can say. Okay, minus omega t. Now if we solve this, then we get e naught 2 sine, within bracket it can be written as kx minus omega t and plus k delta x. Okay, so if we consider that k delta x be delta, so delta is the phase angle. Okay, so delta is the phase angle, so we can easily write down that E2, that will be equal to E naught 2 sine kx minus omega t plus delta. So up to here I hope and I believe that each and everything is clear now. So delta can also be written as omega divided by v. Okay, and it is also equal to, as you can see here, it is equal to k times delta x, so it will be k times delta x. Okay, so this thing you have to remember that what is the value of the delta or the phase angle here. Now what if we have two waves, first is your wave E1 and second one is your wave E2, are superposing. Okay, are superposing, and if the two waves are superposing to each other, then we have a resultant wave. So we know that the resultant wave E, that can be represented as E equal, as you can see here. So the two waves are having amplitude E naught. Okay, E naught 1, E naught 2. So in the same pattern we can write down that E naught. So this is the equation of the resultant wave, and sine, the same pattern we will follow, that kx minus omega t are the same in the wave 1. As you can see, this is the equation of your wave 1 and this be the equation of the wave 2. It means the kx minus omega t is similar. So we can write down that kx minus omega t, but the phase angle must be changed. So we will take phase angle here theta. So this will be the final equation, or we can say the resultant wave, or we can say that it is the interference wave. Now E naught can be easily calculated by using the formula for the resultant, that will be in square root E naught 1 square plus E naught 2 square plus 2 E naught 1 E naught 2 cos delta. Okay, so this is the amplitude of the interference wave. So up to here what we have done, we have to choose two equations which are the transverse wave. Okay, first is your E1 equal E naught 1 sine kx minus omega t. Then we will take the another wave, or we can say second wave E2. So E naught 2 times sine kx minus omega t plus delta. Delta is the phase angle between the two waves E1 and E2. In the same pattern, in the same phenomena, we will have the resultant wave after the superposition of the two waves, and that is equal E naught sine kx minus omega t plus theta. So here E naught is the maximum amplitude of the resultant wave. So that can be easily calculated by using the formula of the resultant, that is E naught equal under root times so E naught 1 square plus E naught 2 square plus 2 E naught 1 E naught 2 cos delta. So I hope and I believe that up to here each and everything is clear to all of you. Now what we have to discuss about the conditions of the interference. So if we have that this path difference, so this is taken as delta x. Okay, so this one is delta x, delta x. So if delta x equal 2n lambda, okay, then we get the bright fringe. Bright fringe. Okay, and if we have delta x equal 2n minus 1 lambda, then we get the dark fringe. So these are the two conditions what we have to learn, that if the path difference equal to 2n times lambda, then we get a bright fringe, and if the path difference is 2n minus 1 times lambda, then we get the dark fringe. Okay, so I hope and I believe that up to here each and everything is clear to all of you. Also, one thing you have to know that the bright fringe represent maximum amplitude. Okay, so if we have maximum amplitude, then it is the bright fringe. Okay, and for the small amplitude, okay, so for the minimum amplitude, not small, okay, so dark fringe, we can say dark fringe means the minimum amplitude should be there. So if the amplitude is maximum, then we get the bright fringe. If the amplitude is minimum, then we get the dark fringe. So here you can see that this is the amplitude, this is the amplitude. So how we can get the maximum amplitude if cos delta will be minimum? Okay, so if cos delta is maximum, then we have the maximum amplitude. If cos delta is minimum, then we have the minimum amplitude. Okay, so by using these two conditions, means firstly we will take maximum amplitude and we have the condition of bright fringe. Then we take minimum amplitude and we have the condition of the dark fringe, and then we can easily able to calculate the value of delta x. We have to calculate the value of the position of the point of the we can say the constructive interference or destructive interference. Constructive interference or destructive interference simply represent the brighter fringe and the dark fringe. So I hope and I believe that this lecture is quite easy to understand to all of you. So thanks for watching me, thanks for listening me. So best of luck to all of you. Thank you.